So people always ask me, are logarithms difficult? And I always tell them, yeah, if you're an idiot. Otherwise, they're easy. Okay, so we have 5 basic rules here. The first one, logarithms convert product to addition. Okay, so you have log x times y, that's log x plus log y. Rule number 2, logs convert division to subtraction. Log x over y, log x minus log y. Rule number 3, logs convert exponentiation to multiplication. So if I have log of an exponent, log of x to the y power, that becomes y times log x. Okay. Rules number 4 and 5, they say that log is the inverse of exponentiation. So if I have a base b and I raise it to the power of log base b of x, I get x back. If I take log base b of b to the x power, I get x back. So it's kind of like, you know, you take your shoes off, you put them back on. Put your shoes on, you take them back off. You get back to where you started. Right? Like this is similar to, let's say we have an x. We add 3 to it. Well, how do we get x back? We subtract 3. This gives us x. If we subtracted 3, how do we get x back? We add 3. There you go. Okay, so the goal today is going to be to use these 5 simple rules to solve logarithmic equations. Let's say I have an equation like this. The most important of these 5 rules are the last 2. They say logarithms are inverse to exponentials. So if I have a log, how do I get rid of it? I introduce an exponential. Example here. Let's say I start with this equation. 3 log base 4, 2x plus 6 plus 1 equals 7. How do I solve for x? Alright, the very first thing you want to do is you want to isolate all the weird stuff. In this case, that's a log that's wrapped around the x. So first, we're going to subtract 1 from both sides. On the left, that cancels. On the right, we're just left with 7 minus 1, that's 6. So what do we have now? We have 3 times log base 4, 2x plus 6 equals 6. Okay. Now how do we isolate this further? We divide both sides by 3. Divide this side by 3, divide that side by 3. Here, the 3's cancel. Here, 6 over 3, that's 2. We have log base 4, 2x plus 6 equals 2. Okay, now how do we get rid of the logarithm? Well, we know that logs are inverse to exponential. So how do I get rid of the logarithm? I introduce an exponential. Now this is log base 4, so I want to introduce an exponent with base 4. So warning, what you do not do is you do not put a 4 on both sides. That's wrong. Sorry, what you do not do is you do not put a 4 as the power of both sides. What you do is you put 4 as the base of both sides. Right? If log base 4 of something equals 2, then I introduce 4 as the base. That means 4 to the power of log base 4 of that thing is the same as 4 to the power of 2. Let me rewrite that over here. Okay. 4 to the power of both sides. Okay? Now why did I do that? Well, I did that so we could get some cancellation. We have 4 to the log base 4, 2x plus 6. Boom, gone. Why? That's rule number 3. Now on the right hand side, we have 4 to the power of 2. Means 4 times itself 2 times. 4 times 4, that's 16. So this drops down. We have 2x plus 6 equals 16. Okay, now this is an easy algebraic equation to solve. Subtract 6, 2x equals 10. Divide by 2, x equals 5 is our answer. Okay, so you might be asking me, well, that's all well and good, but then how do I check my answer? Well, I'll show you. You always check your answer by plugging back in. Well, so I checked. I want to plug this x back in to the original equation. I want to see, is this equation satisfied? Well, let's do it. 3 times log base 4 of 2 times 5 plus 6 plus 1 equals 7. Is that true? I don't know. I'll put a little question mark. Let's evaluate. 3 log base 4. Okay, 2 times 5 is 10. We add 6. Get 16 plus 1. Is that 7? Who knows? Let's simplify a little more. Well, we have log base 4 of 16. And we know that log base 4 is the inverse of the exponential function with base 4. So how can we rewrite 16 as a power of 4? Well, 16 is 4 squared. There we go. Okay. Now look over here, rule number 5. We have log base 4 next to 4 to a power. Boom, cancel. That's gone. The power, the 2, that drops down. Now 3 was multiplying all this stuff, so we have 3 times 2 plus 1. Is that 7? I think it is. We're good.